Time is a fundamental aspect of our existence. It is an ever-present force that shapes our lives in ways we often take for granted. We experience it as a constant flow, moving from the past through the present and into the future. This seamless progression allows us to grow, to learn, and to evolve. Time allows us to perceive change, to mark events, and to measure the duration of processes. It is the silent witness to the unfolding of the universe, from the birth of stars to the dance of planets. In our everyday lives, time seems absolute and unchanging. We set our schedules by it, celebrate milestones, and reflect on memories. Yet this perception is just a small part of a much grander picture. However, when we delve into the vastness of space and the mysteries of the cosmos, our understanding of time takes on a whole new dimension. Out there, time behaves in ways that challenge our everyday experiences and intuitions. Space and time are not separate entities but are interwoven into a single fabric known as space-time. This concept, introduced by Einstein's theory of relativity, revolutionized our understanding of the universe. This fabric is not static. It can be warped and stretched by massive objects like stars and galaxies. The presence of such massive bodies bends the very fabric of space-time, creating phenomena like gravitational lensing, where light from distant stars is bent around a massive object. Near the most extreme objects, like black holes, time itself can slow down dramatically. This effect, known as time dilation, means that time passes differently depending on the strength of the gravitational field. The mysteries of space-time continue to intrigue and inspire us, opening up possibilities that stretch the imagination. Could we one day travel through wormholes, connecting distant points in the universe? The journey to understand time is as boundless as time itself. Imagine a vast, empty stage. That's space. Now imagine actors moving across this stage. Their movements, their interactions, their stories, that's time. Time, in this sense, is not just a measure, but an integral part of the universe's unfolding drama. It's not an independent entity that marches forward at a constant pace. Instead, it's intricately linked to space, forming a flexible, dynamic fabric. This concept, known as space-time, is fundamental to understanding the universe's grand scheme. It challenges our everyday intuition about time, suggesting that it's not rigid, but rather a fluid entity influenced by gravity and motion. One of the most mind-boggling aspects of space-time is that gravity, the force that holds us to the Earth, can actually bend time. This means that time runs slightly slower in stronger gravitational fields. For example, time runs a tiny bit slower at the surface of the Earth than it does in space. This effect, known as gravitational time dilation, has been experimentally verified and is even taken into account in technologies like GPS satellites, which rely on extremely precise timekeeping. If we rewind the cosmic clock back billions of years, we arrive at an event that marks not just the beginning of our universe, but also the beginning of time itself, the Big Bang. According to our current understanding, the universe originated from an extremely hot, dense state about 13.8 billion years ago. From this point of singularity, the universe rapidly expanded and cooled, leading to the formation of galaxies, stars, planets, and eventually, life itself. The Big Bang is considered the moment when both space and time came into existence. Section 5. Could time end? Now let's fast forward to the future. Just as the universe had a beginning in time, could it also have an end? One possibility is the Big Crunch, a scenario where the expansion of the universe eventually reverses, and the universe collapses back in on itself. In this scenario, everything in the universe, including time itself, would be compressed back into an infinitely small point, essentially a reverse Big Bang. Section 6. The Big Freeze, a cold end to time. Another possible fate for the universe, and therefore time, is the Big Freeze, also known as the heat death. In this scenario, the universe continues to expand indefinitely. As it expands, it also cools, eventually reaching a state of maximum entropy, where no more work can be extracted from any physical process. Stars would eventually die out, matter would decay, and the universe would become a cold, dark, and empty place. In this scenario, time would still exist, but there would be no meaningful events or changes to mark its passage. Section 7. The Big Rip, a universe torn apart. A more dramatic and violent end to the universe is the Big Rip. In this scenario, the expansion of the universe accelerates at an ever-increasing rate, driven by a mysterious force known as dark energy. As this expansion accelerates, it would eventually overcome all other forces, including gravity, that hold matter together. Galaxies would be torn apart, followed by stars, planets, and eventually, even atoms themselves would be ripped apart. In this scenario, space-time itself would be torn apart, leading to the end of time as we know it. Section 8. Black holes, time-bending mysteries. No discussion about the nature of time and space would be complete without mentioning black holes, some of the most enigmatic objects in the cosmos. These cosmic giants have fascinated scientists and astronomers for decades, if not centuries. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. This immense gravitational pull is due to the black hole's incredibly dense core. At the center of a black hole lies a singularity, a point of infinite density where the laws of physics as we know them break down. This singularity is surrounded by the event horizon, the boundary beyond which nothing can return. Time behaves very strangely near a black hole. The immense gravitational forces cause time to slow down significantly. As you approach a black hole, time slows down relative to an observer farther away. This phenomenon is known as time dilation. If you were to fall into a black hole, from your perspective, time would continue to flow normally. However, to an outside observer, you would appear to slow down and eventually freeze at the event horizon, the point of no return. This effect is due to the extreme warping of space-time caused by the black hole's gravity. The event horizon marks the boundary where the escape velocity exceeds the speed of light, making it impossible for anything to escape once it crosses this threshold. Surrounding the event horizon is the accretion disk, a swirling mass of gas and dust that is gradually being pulled into the black hole. Some black holes also emit powerful jets of energy, which can be observed from great distances. When black holes merge, they create ripples in space-time known as gravitational waves, which have been detected by observatories on Earth. These phenomena provide valuable insights into the nature of gravity and the fabric of the universe. Black holes remain one of the most intriguing and mysterious objects in the cosmos, challenging our understanding of physics and the universe itself. As we continue to study these fascinating objects, we may one day unlock the secrets of time and space itself. Section 9. The End of Time. What would it look like? Imagining the end of time is a truly mind-boggling exercise. Our human minds are wired to perceive time as linear and ever-flowing. Would time simply cease to exist, like a movie projector shutting off, leaving behind a blank screen? Or would it transition into something completely beyond our comprehension, a state where our current understanding of physics has no meaning? Section 10. The Future of Time, Unraveling the Cosmos. The nature of time, its beginning, and its potential end are some of the most profound and challenging questions in science. While we have made significant progress in understanding the universe and its evolution, the mysteries of time continue to intrigue and inspire scientists. New telescopes, experiments, and theoretical models are constantly pushing the boundaries of our knowledge, bringing us closer to unraveling the secrets of time and its role in the grand cosmic tapestry. Section 11. The Search Continues, Unlocking Time's Secrets. As we continue to explore the vast expanse of space and the intricate workings of the universe, we are embarking on a journey that transcends the boundaries of our imagination. The cosmos, with its infinite wonders and mysteries, beckons us to delve deeper into its secrets. We are constantly reminded of the interconnectedness of everything. Every star, every planet, every galaxy is part of a grand cosmic tapestry, woven together by the threads of time and space. Time is not merely a concept we measure with clocks, but a fundamental aspect of the universe's fabric. It is an ever-present force that shapes the very structure of reality. Intertwined with space, gravity, and the very essence of existence, time influences the motion of planets, the formation of stars, and the evolution of galaxies. It is a dimension that we are only beginning to understand. The search for answers about the nature of time is far from over. Scientists and researchers are tirelessly working to unravel its mysteries using advanced technology and innovative methods. The quest to understand time is a journey that spans generations. Each discovery builds upon the work of those who came before, creating a legacy of knowledge and curiosity. In fact, it's a journey that's only just begun. With each new mission, each new piece of data, we move closer to unlocking the secrets of time. Each new discovery opens up new avenues of exploration, pushing us to reevaluate our place in the cosmos. We are constantly challenged to think beyond our current understanding and to embrace the unknown. As we gaze at the stars and ponder the vastness of the universe, we are reminded of our own smallness and the incredible potential for discovery that lies ahead. To marvel at the profound mysteries that still await our understanding is to acknowledge the endless possibilities that the universe holds. The journey to unlock time's secrets is a testament to human curiosity and our unyielding desire to explore the unknown.